Hello everyone, welcome back to our channel. This is Asim and I'm quickly going to show you the 30,000 machines that were vulnerable at the time I was scanning it, or the cups vulnerability that was recently released. On the screen you can see the markers red dot that shows the machine where that particular vulnerable machine was on the globe. And on the right you can see the count of around 28,000 machines that were vulnerable. In this video we're going to talk about 5 different CVs in the cups package, how the researcher Simon found it, what happened after it, and some of the repercussions of it, some of the other exploits that people found, like Akamai found how people could do DDoS using this. With that said, let's start the intro. So this is the write-up by Simon where he talks about how he found the cups vulnerability. Cups is a Linux package that allows printing. The full form is Common Unix Printing Service. So any Unix machine basically that wants to send a print job to a network attached printer uses this particular package. Now all the latest releases and even all the vendors have released packages update for it. So most likely if you have updated your machine, you would not be vulnerable. I'll quickly talk about how he found it and what are different vulnerabilities. So if you see the summary here, there's this cups browse package, there's a libcups filter, libppd and cups filter. I'll try to explain it in plain English what it all essentially boils down to. So there were multiple vulnerabilities. One of them was being that the package was listening on port 631 on UDP from all the IP addresses. So it was not restricted to a local host or the local network, rather anyone from the world could basically connect or send data to that particular packet, the particular port 631. That increased the attack surface a lot, and that is why it has a very high CVSS score. The other issues with this particular findings was that the libppd package was not properly sanitizing the input that was being given into the PPD file. PPD file is the post-script print directive. It essentially tells what kind of printer it is, where it's located, what are different features and all that. Let's quickly go over the attack chain. So once a specially crafted packet is being sent by the attacker to a vulnerable machine, the machine could be your computer, your desktop, your laptop, or Raspberry Pi, any machine that's running a Unix server with the cups vulnerable package version, it's machine where you would send this packet. It's a small packet, less than 80 bytes, I think it's 80 bytes packet, and specially crafted UDP packet. You send it to that particular machine would think that you are a printer, and it would send back a post request with asking you for the attributes of it. You revert back with a specially crafted attribute string that would get stored into the PPD file. Now anyone who connects to that particular printer, the vulnerable or the malicious printer that you are hosting, if they send a print job through that printer, it essentially executes that report code. The beauty of this whole exploit is it's very simple to understand. It's very straightforward. The attack exposure is huge because the port 631 was by default running throughout the globe. In the recent package, the updates, they have restricted that port 631, and that's why for creating this vulnerable machine, I had to download a previously vulnerable packet and then try to show you how that whole thing starts. Let's quickly go to a terminal and see how this works. So on the top you see this is the server.py, the port 8399 is exposed on it. This is my machine where the map you were seeing, so it's where I am getting a ping back from the vulnerable machine. On the bottom right, this is the vulnerable machine. On the left, this is my local machine. Top and the bottom right are the remote instances, 2 different instances. On the bottom left corner is the local machine. So I send this particular specially crafted packet. You can see the callback server is 167.99156.253.8399. It's the top one. And there's a particular path /filter/ from Python. That from Python could be anything, ABCD, whatever you want. The target IP where I'm trying to send this particular UDP packet, that's the right one, the vulnerable machine, and port is 631. If you see on this particular vulnerable machine port 631 here, this is essentially exposed. I'll show you the package as well. So if you see the cups browser package, it's 2.0.0.1210. And if you see the netstat command, you would see that port 631 is exposed to the world 0000. All the IPv4 addresses could connect back. Now quickly, let me send this packet, and once I send this packet, it goes to the right machine, that's the vulnerable cups machine, and it tries to connect back to the top machine, which is the server where it's running. So the server would print out everything, and you should quickly see it. see what we got here. So we got multiple requests here. This is where it starts. From Python, there's a post request. The headers you can see here, the user agent. User agent also exposes the particular Linux headers. So Linux 6.8.047 generic, 64-bit architecture. IPP is the Internet Printing Protocol, version 2.0. Body is the get attributes, printer, URI, IPP, and then this whole thing is there. So basically, you would have to, if you would want to exploit it further, you would have to revert back to the particular specially crafted PPT file as a URI or as a string. And that's when it would get stored into a temporary folder as a printer attribute. And someone, if they try to connect to that printer and print a job, that particular file would get executed on the machine where we exploited it. This is the vulnerable IPP file, and the researcher here, it tries to just send echo1 to the temporary folder with creating a file called fonts. That was just a proof of concept. Now, as I was talking about the repercussions of it, so because even though this was fixed, and meanwhile while this was being fixed, the Akamai did a After Effects research, I would say, where they thought that this could be used as a DDoS. So you can see the global map here. There's all these vulnerable machines, and you can see the user agent as well. So user agent basically prints the Linux version and also the architecture, where the 64-bit architecture are different, and you can zoom it and see all these things. I got almost 2.7 million packets back, and I was running a Go server, especially A10 Go server, which was just ingesting data and dumping it on the ELK stack so that I can eventually create a map out of it. And you can see in less than 36 hours, I got almost 2.7 million hits. Let's talk about how this whole thing was created. I set up a machine where I was listening. I wrote a Go script that was listening to any packets coming in, any inbound connection. All the inbound data was being stored into the ELK stack with the IP and geolocation and all those things. On the same server, I set up UDP packet sender. So I sent packets to all the IPv4 addresses across the globe, and the Go server was waiting to listen on them. As soon as the server got back a connection, it dumped the connection onto the ELK stack and reverted back OK to the vulnerable machine. That's how pretty much it. And the ELK stack with the Kibana dashboard, I was easily able to create a map out of it. That's it. If you want to learn more about how all these things were written, how these things could be done, please comment it below and I'll try to explain the code itself. That's pretty much about this exploit. If you want to read about this exploit in detail, go to the Evil Sockets blog. I have added the links for that in the description of this video. The Akamai links is also there, and there's also a link to Shodan where you can see the current number of cups vulnerable browser online. With that said, thank you, take care, and have a nice day.